doing today is to connect this temperature sensor. So we're going to be doing some soldering here using these pins. Okay, let's see. So if we go, this is my local supplier. If we go under sensors, temperature, I've got this one. So it's a 18B20 digital temperature sensor with 5-meter cable. You can see its specs. Okay, so essentially this is what we needed, this code. For that, here's a schematic for linking this temperature sensor to a Raspberry Pi. But you see this resistor for 4,700 ohms. This you will always need with using this temperature sensor. Doesn't matter if you use Arduino or Raspberry Pi. So that would be the first task to get that circuit working. You can see an example of that same resistor if you use multiple temperature sensors. They can share the same data line. Okay, so that's all I needed. I needed to know if it's what resistance that resistor needs to be. And what I like to do is put them into the breadboard, just hold them upright, and then it's easier to solder. What works well is if you first put some onto the surfaces. Just a little bit. Put them in vertically so that the connections run this way. Next is our resistor. I got this nice little kit. We're looking for 4.7K. Here it is. It's a good idea to just double check, so I'm going to quickly show you how to use one of these. Yeah, close enough to 4.7K. You can see here's our resistor, and it's supposed to go between ground and data. What this does is it pulls up the data to your 5 volts or to power. Right, so instead of it floating, it will default up to a true or a 1, and then to transfer data, what this pin will do is it will pull that down to 0 because it will be stronger than the power that can flow through this resistor. I hope that makes sense. The result is this green pin will read on or off 0 1s, basically 0 or 5 volts. And that's the data coming from the digital temperature sensor. So we don't get an analog signal out. This chip turns it into a digital signal for us that we can read accurately. Red is power, black is ground, yellow is data. If you're not sure if yours has different colors, you can check online. I know some of them have green cables as well. So we need to put this resistor between data and power to pull up the signal. Okay. Okay, so the next step is let's hook it up to Arduino and see if we can get data out of it. I'm going to use the same pinouts as in the previous schematic, so we'll use ground 5 volts and pin 2. Okay, I like to use the right colors. Go to Sketch, include library, manage libraries. We search for DS18B20. It's the code of the sensor. Let's just use the top one. There's quite a few people. I did check out this info. It seems to be a good one. Let's have a look. Okay, so after it's installed, examples, just see it fit into the screen. Examples, Dallas temperature, and there's one down here that won't be in this video, but it's called simple. So here's a little example. Close these other ones. Okay, let's have a look. So 1 wire bus pin 2, I guess that's what people always use. It will initialize that. Then it creates a serial connection, so it can actually report to us. Let's keep that on the defaults. Then it requests the temperature sensor. It says done if it did that, and then it will just print line the first temperature sensor that it detects. Let's upload that. No such file directory. Great. 1 wire. So it's got a missing library here. Okay, let's try again, verify. Now it's compiling fine. Let's upload. And to see the output of the serial connection, go to Tools, Serial Monitor. Mine's set to the wrong baud rate, so just set it to 9600. Okay, there we go. So it's reading temperatures. To test that, I'll just hold this temperature sensor in my hand, and you can see the temperature is going up. 23, 24, 25. If we cool it back down. There it's starting to drop a bit. So the next step would be to link this through to the cloud.